Hey guys, welcome back to another video and I hope you guys are doing extremely great, and today we are going to solve this question contains duplicate. And for this question today we will be learning three different approaches: the brute force approach, the better approach and the optimized one. So make sure you stick around till the end with your pen and paper and let's get started. Now let's understand what the question is saying. So we are given an array of integer and our task is to check if any element appears at least twice in the array, and if it does then we need to return true, and if it does not then we need to return false. Okay, so if you look at these array elements, you will notice that this one is repeating. So that is why we are returning true. But here in these array elements, you can notice that all the array elements are distinct. All the array elements are unique. So that is why we are returning false. Okay, so how we are going to solve this question? Let's see. So let's first discuss about the first approach. Okay, in the first approach, what will happen if these are the array elements and I need to check for duplicates? So the very basic idea that should come in my mind is to check every element with every other element and will compare for duplicates. Okay, so I will start from here. I will check this one with the remaining elements, and if at any point I find that this element is equal to the other element, then in that case those two elements will be duplicates, and from there we can simply return true. Okay, as simple as that. Here what we are doing, we are checking every element with the remaining element and comparing them if they are equal or not. If they are equal, that means they are duplicate, but if they are not equal, that means they are not duplicate. We will simply move ahead. Okay, so that's how the code will look like for this particular approach. So what we are doing here, we have an outer loop that will help us to traverse all the array elements one by one, and then we have an inner loop, and with this inner loop what will happen, suppose I is here, j will start from I plus 1, j will here, this is I and this is j. And now what we are doing, we are checking if nums of I is equals to nums of j. If these two array elements are equal, that means they are duplicate, and so that's why we are returning true. But if these two loops are executed, that means we haven't found any duplicate elements yet. Okay, so that's why we are returning false at the end. Okay, so that's how we can solve this question using this brute force approach. And here if I talk about the time complexity, you can clearly see that for every element we are checking the rest of the elements. So this will go big of n and this will also go big of n, where n is the size of the array. So that's why the time complexity will be big of n square. Okay, and this is not good for large test cases and will definitely going to give us TLE. So that is why we are not going to use this approach. This is just the brute force approach. Now we will think of optimizing it. So how we can optimize it? So in this brute force approach, the time complexity came out to be big of n square. Now we need to optimize it. Something like big O of n log n or something like big O of n. We need to optimize it like this, right? So let's think of optimizing it. Okay. So in this previous approach, what we did, for every element, we are comparing it with the rest of the elements, right? But what if I sort this array? Okay, after sorting, this array will look like this, right? So this time I know that I don't have to check for the rest of the elements. If I start from here, then I just need to check the next element. If they are equal, that means they are duplicate. So immediately I can return true. Make sense what I said? I said that instead of checking every element with all the other elements to compare if they are equal or not, we can just sort them, and after sorting the array will look something like this. Okay, and now what we can do, we have an advantage. Instead of checking every element with all the remaining elements if they are equal or not, we just need to check every element with its next element, and if they are equal, that means they are duplicate. If they are not equal, that means they are not duplicate. So if they are equal, they are duplicate, and hence we can return true. Okay, so that is my idea. So what I'm gonna do, 1 2 3 1, this is the array that is given to us. I will sort it. You can use any sorting technique here. For the time being, I will be using inbuilt function. When I will show you the code, I will be using an inbuilt function for sorting this array. Okay, so after sorting, it will look something like this, right? So now we know that if there are duplicates, then they will sit next to each other. Okay, as you can see over here, if these are duplicates, then they will definitely going to sit next to each other. Okay, if there are other duplicate, then they also will sit next to each other. Okay, so that's how we need to think. So the same thing we are doing here in the code. What we are doing, first we sorted the array. Okay, now the array that we had earlier was something looking like this, but after sorting it will look like this. Okay, and now we know that we need to make comparison only with the next elements. Okay, for example, for this I'm going to compare it with the next element, right? So what I'm going to do, I will start from I equals to 1 and then I will go till the end, and I plus plus. Okay, if nums of I equals to nums of I minus 1, if these two are equal, that means we need to return true. So I equals to 1, I will start from here, okay, and this is I minus 1. So I'm gonna check if nums of I is equals to nums of I minus 1. If they are equal, that means they are duplicate. So we need to return true. Okay, let's say we have another array. For example, if this is going to be my array, right? If this is going to be my array, so I will start from I equals to 1. I will start from here. I will check, is this nums of I equals to nums of I minus 1? No, it's not. Okay, we will move ahead. Now I will, again I'm gonna check if nums of I equals to nums of I minus 1. This time these two are equal, so we are gonna return true. So here you notice that we are not checking the every element with the rest of the elements. No, we are not checking every element with the rest of the elements. We are now making comparisons with the next elements only. For this element, I just compare it with the next element. For this element, I just compare it with the next element, because after sorting, we know that if there are duplicates, then they are definitely going to sit next to each other. Okay, so that was the whole point, and that's how we can solve this question using the better approach. Okay, and in the brute force approach, we saw that the time complexity was big of n square, because there we have two loops, and for every element we are checking it with the remaining elements. So that's why the time complexity was big of n square, which was not good for large test cases. We then optimized it, and now we will figure out what is the time complexity in this better approach. Okay, so you can use any sorting technique here. For the time being, I have used inbuilt sorting function. So let's say it's gonna take n log n, big of n log n in sorting. Okay, big O of n log n in sorting, and big O of n in traversing the array. So big O of n log n plus big O of n. So the less dominating terms we can ignore, and hence the time complexity will be big O of n log n. So that is how we can figure out the time complexity, and in this case the time complexity is big O of n log n, because we have ignored the less dominating terms. So this is the time complexity is going to be. Space complexity is constant, because we haven't used any extra data structure here to store something, just few variables. Okay, and you can clearly see that this complexity is much better than this one, big of n square. Okay, so now let's look at the optimized approach. You need to remember one thing. Whenever you are in a situation, whenever you are in a situation where you need to find out frequency, okay, where you need to check for pair, where you need to check for duplicates, where you need to check for unique elements, you will always think of a hash map and a hash set. In this particular question also, we need to check for unique elements, right? We need to check for the duplicate elements. So that is why I will be thinking of hash map and hash set. Okay, so how we are going to do this question, with the help of a map or with the help of a set? I will be using set here, because set contains unique element. Set contains unique element, and I want unique element only. Okay, so that is why I'm using set here. So what I'm gonna do, this is going to be my set. Okay, I will start traversing the array. I will check if this element already exists in my set or not. If it exists, then that means this is a duplicate element. Okay, so we can return true. But if it does not exist, then we need to add it to the set. So in my case, I will start from here. I will check if this one already exists in the set. No, it's not. So I'm gonna add it into my set. Okay, I will move ahead. I will check if this two already exists in my set. No, it's not. So I'm gonna add it into my set. I'm at 3 now. So I'm gonna check, is this 3 already exist in my set? No, it's not. So I'm gonna add it to my set. Now I am here. I will check, is this one exist in my set? Yes, it is. So that is why this means this element we have already seen before, and this is a duplicate element, right? So we can return true, because we found the duplicate element. So that's how we can solve this question using the set approach. And here you can see we are not sorting, we are not using two loops. In just single pass we did the question, and now we will figure out what will be the time complexity. But before that, I'm gonna show you the code, how the code will look like. Okay, so here we have a set. Okay, and what we are doing, first we are traversing all the array elements, and we are checking whatever the element that I am on. Okay, I'm gonna check, is that element already exist in the set? If it does, then that means that is a duplicate element, so we can return true. Okay, but if that element not exist in the set, that means we need to add it to the set first. So we are adding it, and if the loop completes and we haven't returned anything, so that means in my array there is no duplicate elements, so we are finally returning false at the end of the logic. So that's how we can solve this question using this optimized approach. Here you saw that we haven't used two loops, we haven't used the sorting approach. In just single pass, with the help of this set concept, we solved this question. Now let's talk about the time and space complexity. So time complexity will be big O of n, because we are just using a single pass and all the lookups in this set is going to be in constant time. So the time complexity is going to be big O of n because we are just using a single pass here. Now let's talk about the space complexity. Here we are using extra space, that is of storing elements inside this set. So that is why the space complexity is going to be big O of n. So the space complexity is going to be big O of n because we might end up storing n elements to the set, and the time complexity was also big O of n. Okay, so this is going to be the time complexity and this is going to be the space complexity, and that's how we discussed all three approaches. So that's it for today. I hope you got all the approaches now, and if you did, make sure to like, share and subscribe, and I will see you in the next video with another DSA concept.